slides. So getting into social data analytics, the machine data analytics. If you take any of the things, the smarter cities projects, where I want to talk about can I streamline traffic? Can I figure out things are moving smooth or whatever? There are so many machines which are generating data. And when I say machines, it could be devices, or it could be very high-end machines like a mainframes. It will range from all kinds of machines, right? They're generating, and as you know, these machines generate data in all kinds of log formats. Within them, applications have different logs in themselves, and they are generating a lot of data. Similarly, when it comes to the healthcare, I talked about the data baby use case. Again, that's machine data, right, in different forms. We're talking about I want to look at what the criminal history of some suspect, what they are doing, are they calling each other, is there any pattern there, how do I actually track those suspects and so on. All that comes under the law enforcement investigating agencies. Again, huge amount of machine data getting generated. All this real-time machine data. So what we are talking about is handling this machine data. Now, let's look at some of the challenges that handling machine data brings with it. One is the data sources are diverse, and the formats are quite complex, and sometimes they're following some standards, and most of the time they're not standard. So either they're vendor specific or they're application specific within a vendor-based application, and the data, the volume is extremely large. I have seen cases where some customers have had almost close to, in one data center itself, close to 2 terabyte logs generated every day, like every day. And the kind of analysis, now if you want to do any analysis, you have to have, say for example, I want to detect, is there any correlation of multiple events across the logs? Has there been a pattern there? Is it going beyond the pattern? If I want to do any of those things, I may want to store a year or 2 years of data, right? And then maybe I want to build index. I'll just get to why we need the index. Then we're really talking about large-scale indexing of things. And then next thing is, how do I really visualize all this data? How do I get any sense of it, out of it? And if things are happening, can I get anything in the real time? So on. Right? But more than anything, key is in the machine data analytics is the formats are varied. And another thing is, suppose there is a, just let's consider more on the logs, machine logs itself, right, than any other set of data. If there is a failure, and I want to figure out a root cause, why something failed. Now, if there is a failure in the application, right? So think of that application is built on a, on a middleware, and it uses a database, and is sitting on an operating system that uses a network and so on. Now, in any of the layers, right, there is a middleware, database, operating system, or network, or physical, anywhere things might have gone wrong. So if I just look at application logs, I may not be able to get anything out of it. So I need to somehow figure out what was the common thread across all these different layers. In other words, can I build a session across all these things so that a particular transaction hit all these layers, and whenever the transaction failed, there was this particular pattern. And then I can look at previously whenever this happened, has it been the same case? Now this is possible only when I integrate analysis across all the layers. Just as one example. Now this is when I'm talking about one machine in all the layers, but typically it will be clusters of machines in the real world. So I need to figure out how do I manage all that. And these are some of the challenges that we are facing. So in the next slide, I'm showing you where we're heading actually when it comes to. Some are available, some are still we're working on. Inside, look at just the inside part of it. The left side shows the various log formats and sources, and the inside we're talking about is what are the root causes, what can I find out pattern detection, anomaly detection, and can I predict failures? One is something happened, I give the root cause. And now second thing is I want to do something preventive. Can I really predict a failure before the failure happens? And the other one is, can I do any resource management? Again, it kind of comes to the prediction part of it, that these set of machines are going to go down. Or this particular fan, the way it is behaving, I know in exactly 3 days it's going to go down, so I need to replace it. Right? So that kind of the resource planning that I can do with it. Okay. So now let's look at the steps involved in order for us to arrive at these insights. Right? What do we need to do? First thing is we need to figure out how do I ingest the machine data into the system, whether it's a real-time or a Hadoop kind of a system. Then is how do I give a structure to it? Right? In order to do a structure, I need to extract. If you look at any log or any machine data, there will be some things. There will be a date, typically a timestamp, and if there is an error message or something, what is the error message, and which component that came from, which machine this happened, it could be IP, and some other such information. Right? So think of them, each of them as individual entities. So there has been a traditional way of doing it, where you write parsers for each type of machine log. Now, because there are so many thousands and thousands of types of machines, it almost becomes impossible for any one application or any one framework to give you all those things. So the parsers writing a parser becomes a headache, right, over and over. So the approach we follow here is we look at these common entities and give common extractors. So for example, date can occur in some 15 to 20 different formats. So we have written all those extractors using our text analytics capability. Again, as earlier mentioned, the text analytics capability is one, because it's easier to write, and the second thing is extremely fast to pick up what they're interested in. Then I want to do faceted search, and then I want to do a large-scale indexing. Where it comes is I want to search for some particular event happening, right? And what happened around that event. So it becomes very important for me to build a search index. And this is not like a database index. This is the Google type of text search index. And then I want to do certain transformations so that I can make it available for some statistical modeling and apply certain machine learning techniques. Now, where we apply statistical modeling and machine learning techniques,